This is a substitution principle with polynomial limits. When attempting to algebraically determine a limit, first always try direct substitution. In other words, when attempting to find the limit of this function as x approaches a, first try to find f of a. Just substitute in a for x. So in this example, I've got this function. They want us to find the limit of this function as x approaches 1. If I substitute it in, I end up with 3/2. And guys, that's right there tells me as my x value gets closer and closer to 1, my y value is going to get closer and closer to 3/2. Okay. Now, if upon direct substitution the denominator of a quotient approaches 0 and the numerator approaches a non-zero number, then the limit of the quotient is not an indeterminate form. In fact, a limit of this form never exists. Now, earlier in another video, I had 0 over 0. We could factor, and then we could go ahead and do the problem. But if I end up with one that I have a non-zero number in the numerator, but a 0 in the denominator, then I just have to say it doesn't exist. Now, I have an example here. So in this one, I've got x squared minus 1. Notice this is a difference of perfect squares. And this one right here, I've got this quantity squared. I'm going to go ahead and factor. So there's my difference of perfect squares. This is this quantity squared. The x plus 1's, I can cancel those since they're like factors, and I end up with this. Now we need to find the following. The limit of this function is x approaches -1. If I do direct substitution, I end up with -2 over 0. From the last statement right above, if I have a non-zero number in the numerator but 0 in the denominator, it does not exist. Let's try 0. If I put 0 in, I end up with -1 over +1, so my answer here should be -1. There that is. Let's try substituting in a +1. I end up with 0 over 2. 0 over 2 is legal. It is 0. Now there is another video that I'm going to be attaching. I'll be doing a little bit later. Just more examples, and you need to look at that. Thank you. Bye-bye.